Hello viewers, so today we are going to learn about session 3, that is on classification and suitability of pumps for the unit 2 installation of sprinkler irrigation system for the job role of micro irrigation technician. So let's see what is a pump. A pump is a mechanical or an electromechanical device which moves fluids, that is liquids or gases, by mechanical action. In micro irrigation, the pump selected must be capable of supplying water at the required pressure and discharge the water for the efficient functioning of the system. Classification of pumps. Pumps can broadly be classified into two types: positive displacement pump and non-positive displacement pumps. Positive displacement pump. It makes water move by tapping a fixed amount and forcing that trapped volume into discharge pipe. Pumping takes place by to and fro motion of the piston or diaphragm in the cylinder. Non-positive displacement pump. In non-positive displacement pumps, water is pressurized by the rotation of propeller and the water pressure is proportional to the speed of the rotor. Positive displacement pumps can be classified as rotary or continuous type and reciprocating or cyclic type. Rotary or continuous pumps. In these pumps, water moves using the principle of rotation. The vacuum created by the rotation of the pump captures and draws in the water. These pumps are capable of pumping more water than reciprocating pumps. For example, lobe pump, screw pump and radial plunger pump. Lobe pump. Inside a lobe pump, there are two lobes that counter-rotate without touching each other to create suction. As the lobes rotate past the suction port, the suction increases the volume of products between the lobes, which draws fluid into the pump casing. The lobes drive a predetermined amount of fluid through the pump and out through the discharge port. Screw pump. A screw pump is equipped with screws that mesh together and rotate within a cylinder cavity or liner. The fluid enters the suction side of the pump and moves linearly along with these intermeshing screws to the discharge side of the pump. The clearances between the screws and the liner are very small, hence the fluid gains pressure while moving through the pump. Gear pump. Gear pump uses the action of rotating cogs or gear to transfer fluids. The rotating element develops a liquid seal with the pump casing and creates suction at the pump inlet. Fluid drawn into the pump is enclosed within the cavities of its rotating gears and transferred to the discharge. There are two basic designs of gear pump: external and internal. Vane pump. Vanes are mounted inside the pump's casing into slots on the rotor. As the rotor turns, the vanes move in and out of their slots. As they do, they make contact with the wall of the pump, which traps fluids between the vane and the rotor. The rotor continues turning, and as each area of trapped liquid rotates past the discharge port, the fluid is forced out. Reciprocating or cyclic pumps. Reciprocating or cyclic pumps operate by drawing liquid in a chamber or cylinder by action of a piston, plunger or a diaphragm. The water is discharged in the required direction by the use of check valves. This results in pulsed flow. For example, piston pump and bucket pump. Now let's see what is piston pump. The high pressure seal reciprocates with the piston. The pump has a piston cylinder arrangement. So as the piston goes away after the delivery stroke, low pressure is created in the cylinder, which opens the suction valve. On forward stroke, the water trapped inside the cylinder is compressed, which in turn opens the delivery valve. So there the water goes out. Bucket pump. It is a pump that uses an endless chain with small buckets attached to it to pull up water from a well. Plunger pump. In plunger pump, there is a high pressure stationary seal and a smooth cylindrical plunger which slides through the seal. Diaphragm pump. This pump uses a combination of reciprocating action of a rubber, thermoplastic or Teflon diaphragm and non-return check valves to pump water. Non-positive displacement pumps. In non-positive displacement pumps, water is pressurized by the rotation of propeller and the water is proportional to the speed of the rotor. These pumps provide smooth and continuous flow of water. For example, centrifugal pump. Centrifugal pump is a pump that operates when water is drawn in the central chamber of a spinning impeller. It is then engaged by the vanes that drive the water outside the pump volute casing. This process transforms the kinetic energy of the impeller into the pressure head used to discharge water from sprinklers or emitters located in the area to be irrigated. One of the limitations of centrifugal pump is that before starting the impeller, casing and intake pipe must be filled with water. This process is called priming. Solar powered pump. A solar powered pump runs on electricity generated by photovoltaic panels which collect thermal energy. It is later converted into electrical energy for pump operation. Generally, a 5 horsepower alternating current solar pump sets with 4800 Wp capacity must be used for lifting the water from an open well or other surface storage structure. We should promote solar pumps. Suitability of pump. The suction and lift are the factors that must be considered while selecting a pump. Suction is the vertical distance between the water to be pumped and the center of the pump, while lift is the vertical distance between the pump and the delivery point like the emitters and sprinklers. Pumps develop differential head or differential pressure. This means the pumps take suction pressure, add more pressure and generate discharge pressure. So the discharge pressure is equal to the suction pressure plus the pump's design pressure. Discharge pressure is determined on the basis of the desired operating pressure, loss of pressure due to friction and change in elevation within the field. While selecting a pump, one must take into consideration the maximum total head against which it is expected to operate and deliver the required discharge. Horsepower of a pump. Horsepower of a pump is the sum of the system's total head plus the pumping lift. The brake horsepower formula is HP is equal to Q into H divided by 75 into A into B, where Q is the flow capacity in liters per hour, H is the total head expressed in meters, A is the pump efficiency and B is the driving efficiency. In this session, you have learned about the positive displacement pumps and non-positive displacement pumps and also the suitability of a pump for a micro-irrigation system. So viewers, I hope you must have learned a lot about the pumps in this session. So keep watching and keep learning. Thank you.